that there is a projectile. And if there is a projectile, it will have we know that a projectile will follow, if it follows a parabola path, the equation of motion should be that of a parabola. This is something which you already know, y square, y is equal to 4ax. So deriving that equation, the final answer that we should arrive at should be the equation of a parabola. Can we do that using Lagrangian? The answer is yes. And this is what we are going to do now. Okay. So then we have got a particle of mass m. Okay. And then a particle of mass m is projected with the initial velocity at an angle alpha, okay, with the horizon. Now what you have to do is you have to use the Lagrange's equation to describe the motion of the projectile. Okay? So the question is very simple. You have got a particle and you project it with some angle alpha. And you know, whenever a particle is projected with an angle alpha, from our idea of vectors, we know that it will have a component along the x-axis and the. So we are going to use the Lagrange's equation to describe the equation or motion of the projectile. Okay. If we just look into this, this will be basically that. So if we just have a clear idea of this, okay. I think we already know that we can actually write it down in this way. We can actually have a component along this direction, we will have a component along this direction, right? So if we say, let's say it's projected with a velocity u, okay? So this will be nothing but u alpha sine alpha, right? Okay, or let's just write down u, not u alpha, or u cos alpha. So these are the two components. So this is something which is already there from vectors, okay? So once said this is the question, okay? And now we have to actually find out how to write down this answer, okay? So for this, what we do is these, okay? So I told you to grab a pen and paper so that you are able to solve it on your own, okay? But then before that, let me just give you some background so that you are able to solve it, okay? So Pxy be the position of the particle at any instant of time. So we have a time t, and Pxy is the position of the particle. How it's like from the previous slide, okay? You can see that P is the point here, okay? So this is the point we are considering. And then we can say the kinetic energy. Now, till now, whatever we have done, we actually talked about the compound pendulum. There was only one coordinate, theta dot. But here, we are considering the xy plane, and we are considering that initially, the kinetic energy is half mx dot square plus y dot square. So you have to consider x dot and y dot as the generalized coordinate, okay? So we've got two coordinates now. Next, potential energy. Now you can take x-axis as the reference level, right? And since it's a let's say a ball is thrown, okay, an object is thrown in a parabola, whenever it is going higher and higher, its potential energy is increasing because of the height. We already know. So potential energy is mgy. We're just taking the height there. And then we can actually say what is the Lagrangian of the system. So the Lagrangian of the system is L is equal to T minus V, which is equal to half M x dot square plus y dot square minus mgy. So if we do that, you should be able to get this, okay? So you take del L del x dot, it will be nothing but mx dot, and del L del y dot would be nothing but my dot. Del L del x should be 0, there is no x there, and del L del y is equal to minus mg. So when we plug into the Lagrange's equation, we have got, those who have not done it, okay, just check this very carefully. So if we just plug into this, del L dt of del L x dot minus del L del x is equal to 0, just do it. So it is mx dot is equal to 0, right? So I can just simply write it down as x double dot is equal to 0. M is anyway constant mass of the system. And then if you go for the next part, we have it as this, right? So we have got y double dot plus g is equal to 0, okay? So there is a minus sign, then there is a minus here. So you basically take minus minus plus. So you can just take m common, so y double dot plus g. Now this is not solved. We still don't have the Lagrange equation. So what we can do is we can actually get back to integration now, because we have to find out what is x, you find out what is y in terms of t, in terms of alpha, okay, whatever variables are given, and then you can obviously do this sum, okay? So what we do a normal integration, right? So what we do, integrate x double dot is equal to 0, and then that can be written as ddt of dx dt is equal to 0, and then dx dt can be written as a, right? Because we already know that if we take ddt of any variable, okay, ddt of any variable is a constant. Here ddt of dx dt, so that means dx dt is basically going to be a constant, right? So you can just do that simple idea, and then we can say dx is equal to a dt, and then we can just simply integrate it. Okay, I've not shown the step, but I think this is very preliminary. Integrate it, integrate dx, you get a x, sorry, and integrate a dt, a is constant, comes out, integrate dt, it becomes t, but then plus b, because it's a indefinite integral. So what is our aim? Aim is to find out what is the boundary values using the boundary condition, what is the constant a and b, and I think we can do it. Okay, but before we use the boundary condition, can we just do this, the second part? The second part is actually a second order differential equation, but then we are just going to make it a bit longer because important. So ddt of dy dt is equal to minus of g. I'll take it on the other side, and so I can just simply put the integration sign. D of dy by dt is equal to integration of minus gd. Cannot use the previous step because there is a g there, right? So we have this here, and then you can take dy divided by dt. Okay, this is integration d of value, so it will dy by dt is equal to minus of gt plus c. Again, indefinite integral, so plus c. And then we can again integrate it. Okay, again integrate it, and then we take dt here on the other side, integrate this, and you find out this result. So again, y is there, the c was already there, and then again we are doing an integration, so it is again another indefinite integral. It's going to be plus t. So this is the final relation that we have. One is for x, okay, and then one is for y, and then I've got four constants here, a, b, c, and d. Okay, so let's get back to the previous one. So you see we have got a and b here, the last line, x is equal to at plus b, and in here we have got c and d. The aim is to find out these values because we don't know what are these values, right? We have to use the boundary condition. So what is our boundary condition? The boundary conditions are very simple, okay? Or the initial conditions, okay? Here, rather than using boundary condition, we should say initial condition. So at time t is equal to 0, that means the ball or object or whatever, it was not projected, it was at the origin. So at time t is equal to 0, x is equal to 0, and then y is equal to 0, right? And then we can also write down what is the x component and the y component of the velocity. So x and y are the positions, right? So we are going to find out what are a, b, and c, and d. Okay, so this can be used using the boundary condition or the initial condition. So at t is equal to 0, the position was x is equal to 0. But then, I have already shown it to you at the first slide that is projected with a velocity u at an angle alpha. So the x component of the velocity would be x dot is equal to u cos alpha. We'll take that as the initial condition, right? And then similarly, y is equal to 0, y dot is equal to u sine alpha at t is equal to 0. Okay. So now I'm not going to go further. Again, take your pen and paper and use these boundary conditions to find out the value of a, b, c, and d. So if you are a bit rusty on practice, you have to just do it in this way. Put the value of time t as 0, put the value of x is equal to 0, and see which variable you get in the first equation where we have x is equal to at plus b. Okay. So how do we do it? We put t is equal to 0, and then your x is equal to 0. Then we can get this relation from the first one, b is equal to 0, right? So x is equal to, then finally what I get is x is equal to at, and then we can just put dx is equal to a dt, right? So do that, and then we have got dx divided by dt is equal to a. Okay, so if we are just missing out on something, let me just check one. Yeah, it is okay, right? Yeah. Okay, so we can take this, and then we can take the x, and then dx is equal to a dt. We can take dx dt is equal to a, or x dot is equal to a. But then we said x dot is nothing but equal to u cos alpha. Okay, so we write down in place of a, we can just write it down as x dot. Okay, and then we can just replace this x dot with u cos alpha and then find it. So what is my x? X is equal to u cos alpha into t. We consider this equation and keep it aside. Okay. Next, the second equation, y is equal to half gt square plus ct plus d. Okay, so y is 0 at the origin again, t is 0, We can put the values, we get D is equal to 0. Now we are left out with only C. We are going to do the same thing. We are going to take again at T is equal to 0. We know Y dot is equal to U sine alpha. So we can just do the differentiation. Okay. If you look into this is Y, not Y dot. If I do Y dot, I can just simply write it down. Dy dt is equal to minus half G of d dt of t square plus C dt of t. So this becomes just C, and the first part of the equation will become 2t. So this is simple. We'll just put that y dot here and then put the equation, and we get minus gt plus c is y dot. But then I already know what is y dot. So I can just simply write it down as u sine alpha is equal to minus g into 0, because y dot was u sine alpha at t is equal to 0. So I'll just put t is equal to 0, put the equation, find out c. So I get c in terms of alpha, I get uh, b in terms of alpha, a in terms of alpha, sorry. Okay, and then we can put the equation. So this is our final relation. We have got rid of the constants, okay, on constants. So we have done this. So we have got two equations now. What are those two equations that we have derived? First is x is equal to u cos alpha into t, and the second is y is equal to u sine alpha into t minus half gt square. Now, can we find out the equation of parabola from here? It's very simple, right? Because what we can do is we can simply write down t from equation 3. We can actually write down t as x by u cos alpha, right? So you can see this. So I think this is simple. Okay. So we can just take this equation 3 and then find out this t. Okay. And then when we do that, okay, when we do that, we can just replace it in the second equation, and then we can write down y is equal to u sine alpha into t. So replace this t value here, and then you get the final relation. So you look into this. This is nothing but the equation of a parabola. Okay. So in a parabolic equation, you can have variables divided into parts, but then there should be a square term. So you see, this is x square. Second term is minus half g x square by u square cos square alpha. So y is dependent on x square, and that means it will follow a parabolic path. So this is the equation of path followed by a projectile and is a parabola. So you see, this derivation is long, but it is simple. So if you are referring to any textbook, okay, you can refer to any book like Goldstein and all. Okay, what they do usually, I've seen that they don't really explain it in a very elaborate way. Okay? So if you do it on your own, if you explain each and every step, things becomes more and more clear. Some of these things are very trivial. These things are simple also. Okay? But then you have to practice it so that you have that confidence. Next question. Once we have this, we can actually go for the next question, which is again another example of Lagrangian. Now, this is something which I'm not going to solve. Okay, I'd like you to solve. If you want to take help from the internet or from any book, it's perfectly fine. This is going to explain few things here. This is something which is informed, or which is taught to you even in your higher secondary. Okay? If you have a circuit with an inductance L and a capacitance C, both of these inductor and capacitor will store energy. Okay, capacitor will store energy in the form of an electric field. The inductor will store energy in the form of a magnetic field. Okay? And they will act as the total energy of the system in case of a Lagrangian. What's the question? The question is, this question comes even in entrance exams. Okay, I have seen this one or twice. We're also going to do one or two questions from entrance exam. I'm just going to tell you which exam it is, probably in the next class. So to find the Lagrange's equation of motion for an electric circuit, okay, just read it through, comprising an inductor L and a capacitance C. Okay, what happens is the condenser is charged to Q coulombs. So that means the capacitor is basically charged to Q coulombs, okay, and the current flowing in the circuit is I amperes. So you know, basically when you are considering LC circuit, we are taking an LC circuit here. You have the current which is responsible for the energy storage in the inductor. Okay, and then of course there is charge which is there, which actually is responsible for the energy storage in the capacitor. So if you go to a very fundamental relation, we can say that in such a circuit, the magnetic energy, okay, the magnetic energy will be stored, okay. The magnetic energy will be stored, and we can write it down in the form of an equation. Yeah. So we can write it down in the form of an equation, half Li square. That's the magnetic energy, okay. And this is nothing but half L Q dot square. Why I write down Q dot? Because when we write down the for a capacitor, we're also writing it down in terms of Q. So it is Q dot, okay. And then the electrical energy is nothing but VE is equal to half Q square divided by C, okay. Or you can write it down as half CV square also. But then we are trying to find out which is the generalized coordinate here, okay. Which is the generalized coordinate, or which variable actually affects the energy, okay. So you can understand, I think I have given one statement before, that what can be the generalized coordinate. It can be position, it can be angle, okay. Now you see it can be charge also, okay. So if you do that, we can actually find out the Lagrangian. So Lagrangian L is equal to half L Q dot square minus half Q square divided by C. And then you can of course find out what is the, you can take Q as the generalized coordinate, and then finally find out is the equation of motion. So I don't want to do this because I've already given you the Lagrangian. This is the more tricky part. Tricky part is over.